Finishing up chapter 2.2 today, talking about polynomials. So we're going to look at number 11 and do a quick review of last lesson. So last lesson we talked about finding the zeros of a polynomial and what the multiplicity of those zeros are and what that means for the graph, and also how many turning points. So that's what we're going to do for number 11 here. So this is on page 14 of the note packet. So let's find the zeros first. To find the zeros, you're going to set the function equal to 0, and then you would factor it to solve for x here. So we're trying to figure out what x equals. Those are our zeros. So for this one, to factor this one, I have 4 terms here. A polynomial of 4 terms is factored by what's called grouping. So to factor by grouping, you're going to first group the first 2 terms and then group the last 2 terms. So group the terms with parentheses here. And then you're going to look for the GCF of each group. So my GCF of x to the third plus 2x squared would be x squared. And then I'd have x plus 2 left over there. And my GCF of negative 4x minus 8 is negative 4. So I'll take out a negative 4. And I have x plus 2 left over there. So now, what's in the parentheses should always be the same. So I have x plus 2, x plus 2. That means I'm on the right track because what's in the parentheses is the same. So I'm going to write that first. So I'm going to write the common factor, my common factor x plus 2. So write common factor there. And then the other factor is what's left over on the outside there. So x squared minus 4. Okay? So that's factor by grouping. Now I can keep going. I can keep factoring this because I know that x squared minus 4 is a difference of squares. So I'm going to go ahead and factor the x squared minus 4. So the square root of x squared is x. My signs are always plus and minus, and then the square root of 4 is 2. All right. So then I have x plus 2 equals 0, x plus 2 equals 0, x minus 2 equals 0. So x equals negative 2, x equals negative 2, x equals positive 2. So my zeros are negative 2 and 2, and negative 2 has a multiplicity of 2 because this factor of negative 2 occurs 2 times. So multiplicity of negative 2 is 2, which that's an even, which means it's only going to touch the x-axis at negative 2. And then the 0, 2 has a multiplicity of 1, which is odd, so it's going to cross the x-axis at 2. And then the turning points, so how many turning points? I do the degree, so the degree is 3, and then do minus 1 is 2. So the max number of turning points is 2 turning points. All right, so that's just a quick review there, and also learning how to factor by grouping. Let's go on to our first new learning target. Learning target for today. I can find a polynomial function of degree n that has the given zeros. So for this first one, number 12, we're given the 0, x equals -3, and we're told that the degree of this polynomial is 2. So first thing you need to know is the factor theorem. So let's talk about the factor theorem first before we get into it. So the factor theorem says that a polynomial f of x has a factor x minus k if and only if, IFF, that's shorthand for if and only if, the polynomial f of k equals 0. So k is our 0 in this case. So basically what this is saying is to find the factor, you would do x minus whatever the 0 is. Okay, so let's look at this example here. X equals -3. So my 0 is -3. So the factor theorem says that this can be a factor, it has a factor of x minus my 0, x minus the 0, -3. So that becomes x minus -3 would be x plus 3. So my factor is x plus 3. So basically, if you're doing this, you're pulling it to the other side. So I would add 3 to both sides here. So x plus 3 equals 0. And then my factor is the x plus 3. All right. And then it tells me I have a degree of 2. So I'm going to use that to finish up my next step. So far, we've used the factor theorem to find our factors. In this case, we only had one 0. Now we're going to check for multiplicity by using degree. Okay, so I want to see if this 0 has a multiplicity. So is there more than one x plus 3? Well, that's my only 0. -3 is my only 0. And I know that this is a polynomial of degree 2. So that means that this has to have a multiplicity of 2. So x plus 3 squared, or x plus 3 times x plus 3. Okay? So I used my degree to see if I had a multiplicity, and we did in this case. And now I'm going to expand by multiplying. We're basically foiling. Okay, so x times x is x squared. X times 3 is 3x. 3 times x is 3x. And then 3 times 3 is 9. Then finally, my last step here. I'm going to combine my like terms. So x squared plus 6x plus 9. That would be the polynomial with the zeros of -3 and the degree of 2. Degree of 2, x squared. Degree of 2 there. All right, let's try another one. Let's do number 13. All right, so I'm going to use my factor theorem to find my factors. So this would be x minus -1. This would be x minus 2, and this would be x minus 4. So x plus 1, x minus 2, x minus 4. Those would be all my factors. Now I'm going to see if any of these have a multiplicity. So I'll check. My degree is 3, so 1, 2, 3, I should be in good shape. No multiplicity here, so I can skip that step and go here. I'm going to expand this out. So I'll start with these first two here. So x times x is x squared. X times -2 is -2x. And then plus 1x minus 2. Bring down that x minus 4. Combine my like terms here real quick. Then I'm going to FOIL again. I'm going to go backwards. I'm going to go x times x squared is x to the 3rd. X times -x is -x squared. X times -2. -2x. -4 times x squared is -4x squared. -4 times -x would be positive 4x, and then plus 8. Okay? And then I'll combine my like terms. And that's my final answer there. All right, you try the last one on your own. All right, so for this one, let's check and see how you did. For this one, I have the factors of x plus 2 and x minus 1 using my factor theorem. And then I'll check for multiplicity. So I know that the degree is 3, but I only have 2 factors here. So one of these has to occur twice. So there's 2 possible scenarios. You could have the x plus 2 having a multiplicity, or the x minus 1 could have the multiplicity. So either of these is correct, but you would have to expand it. And then, so I would multiply this out here. Oops. And I'd keep going. Okay, so that's your first case. If you did the x minus 1 squared, let's see what that looks like. Okay, so 2 possible answers there, depending on where you put that squared. Okay, so that's it for the lesson for today. So now you're ready to do your homework. We're still on page 133. So you're going to do page 133 and then numbers 34, 47, 48, 63, 65, and 66. And then check your answers with the key posted under our Google Classroom stream.